everybody, welcome back. I'm Bud Churchward and this is part 10 in our series of videos about designing printed circuit boards. We have designed the board, we have uploaded the board to be manufactured, they've come back, we've unboxed them, we've built them up, and we've seen them work. We did all that in the first 8 episodes. Part 9 was a bit of an addendum. We took a real close look at the HC595 shift register. It was sort of a continuation of our first part, the discovery phase. We got to see how the registers work. We used a technique called bit banging, where we put push buttons on the breadboard and we simulated the input pins of the shift register to see how they worked. Now it's time to take that same information that we've learned and code it into the sketch that will run on our Arduino. First, let's hook our display panel up to the Arduino. You'll recall that when I laid this board out, I put a duplicate set of pins on both ends of the board so that we could plug the connections in from either side, whichever is the most convenient. So there are 5 pins here, and I've already put some leads on them. They're labeled clock, latch, ground, data, and 5 volts. So let's take these leads and bring them over to the Arduino. Now, you'll notice that I have here a red and a black lead, and they're female, and all the others are male. And you're probably used to plugging pins in over here to get 5 volts and ground. But I wanted to show you that there's another way, a way that I prefer to pull 5 volts and ground off of the Arduino. And it has to do with something that's called the ICSP. These 6 pins right here. ICSP stands for In-Circuit Serial Programming. And 2 of these pins are real handy. This pin right here on the outside, that's ground. So I'll take this black lead and plug it in there. And then the bottom one on the outside is 5 volts. So I'll just plug that in there. We're able to power our display board over here, the panel with all our digits on it, using these pins over here instead of these floppy ones that are on the other side of the board. I've set this up now, so we need to plug in the clock, the latch, and the data pins. The first one we plug in will be pin 2, and this will be our data pin. So I'm going to plug that in right there. The one that comes next, I'll plug that one in right there. And finally the clock pin, which is orange, is going right into pin 4. So the equipment is now wired up and ready for us to experiment while we work on the code. Let's start by doing some of the housekeeping chores. We've hooked up 3 of the pins. Let's define them right here. So let's see, we have an integer. I'm going to call it the data pin, and that is going into pin 2 on the Arduino. We also have the latch pin hooked up to pin 3, and then the clock pin is hooked up to pin 4. Next, I'm going to build an array of all of the bit patterns that we use to create each of the digits that we want to display. I'll set this array up. It'll be an array of bytes. I'm going to call it segs, and just put a couple brackets in here, and then we're going to fill it up here. It requires curly braces. I'm going to put a little comment in here to make it easy to keep track of where the 1s and 0s should be here. Remember, our segments were labeled A, B, C, D, E, F, G, and then we also had one for the decimal point. I'll put that in there. For example, if I want to depict the character 0 in our panel, I'm going to put the binary numbers that represent each of the segments that light up. This capital B tells us that it's going to be a binary number. So the compiler will treat all of the characters that follow this B as if they're binary numbers. That's kind of convenient. To make a 0, we basically light up all of the segments except for the G and the decimal point. So I just fill this full of 1s. And then when it comes to the G, I'll put in a 0, and for the decimal point, I'll put in a 0. That's the pattern that would match the character 0. Let's put in a remark here and show that this is going to be the character 0. Let's do the number 1 next. 1, the A segment is not lit, so I put a 0 in there. We do light up the B and the C segments. Everything else is off, so we'll just put in zeros for all of those. And I'll indicate here that that's going to be the character 1. Let's do one more. This would be the 2 character, and to make a 2, we light up the top segment, that's A. We light up B, so those both get 1s. C, though, is not lit, so we'll leave that as a 0. The D is the bottom one. We will light that up. Going up the other side, E gets lit, and F is not. So that's a 0. But we do need the crossbar in the character 2. So I'll put a 1 in for a G and a 0 in for the decimal point. Now to speed things up, I've already prepared the rest of the bitmaps for all of these characters, and all I have to do is paste them in. And you can see all of them right here. So we've got a full array ready to go here. I've got an extra comma down here at the bottom. From now, I'll take that out. As you'll recall, we use 2 shift registers on this board. We need a second shift register which will handle which of the 8 digits on our panel are actually going to light up. And so I need to set up a byte with a bit pattern in it for that as well. This is a byte that I'll define. I think I'll call it spot, because it'll tell us which spot the character is in. I'm going to set it up as a binary number as well, but it'll be all 1s. And that'll become obvious here later as we work on this. But I'll put in 8 1s right now for the full byte. 1, 2, 3, 4, 1, 2, 3, 4. There's 8 1s. That covers that. Now let's go into setup, and we'll do the usual kinds of things that we need to do to set up pins and whatnot there. That takes care of anything that I think we need to do for now anyway in our setup routine. Okay, now in our main loop, there's not a lot that I'm going to do in here. We're going to use the monitor window to test a few things. If you're not familiar with how serial input and output work, you'll probably want to look at some other videos and see how it goes. But just to get things going, I'm going to simply check in our main loop over and over again, which is what the main loop does, to see if there's anything in our serial buffer. And that's done with this line right here. It checks the buffer to see if anything's in it. This function, serial available, comes back with the actual number of characters that are in the buffer. And if there's nothing in the buffer, then the value will be 0. If the value is greater than 0, we know that something has been entered at the keyboard. And so then I'd like to call my own method. I'm going to name it getDigits. And I'll do my own looping in this function. And the only thing I'm going to do in the main loop function is check to see if anything's been entered at the keyboard. That's the only thing I'm going to do. Okay, let's set up our own method here. We're going to call it getDigits. Set it up right here. We're going to actually read this serial available again. I'm going to set up an integer, and we'll just call it numDigits, and it will tell us how many characters that have come in. and that will equal whatever is out there in the buffer right now. So we'll just put this in again, serial available, like that. Now, there's a problem with this, and that is that the Arduino is just too darn fast. As soon as something is in the buffer, which will happen up here, we're going to jump down and try to find out how much is in the buffer. But we're going to find out before all of that data has made it in. So we have to sneak a little delay in here. Doesn't take much, just like, a 20 millisecond delay before we check the number. That will be enough for all of the digits that we've entered to get into the buffer. And then num digits will become the total number of digits that are in our buffer. Well, next let's set up a variable that will actually be the digit. I'm going to call it new digit. It'll be the digit that has just arrived, and we'll get that by reading the buffer. We'll go serial dot read. Then, so we see what's going on, why don't we do a simple print on our monitor? We'll print line, and that'll be our new digit. We'll print it on the line, and well, let's upload this to our Arduino. And of course, we've got an error before we even get started. And I should have seen this coming. This is an easy one to miss. This line, which I've kind of spread out over several lines, still needs a semicolon at the end, like all the others do. And it was not filled in automatically when I entered that curly brace there. I still need to come back and put the semicolon in there at the end. So I think that should take care of it. Let's try again. It looks like it's going to go. It's uploading to our Arduino, and it's done uploading. So let's go to the serial monitor and see what's going on. Sketch begins. That's our sketch right here. Now, spoiler alert, I already know that we're not going to see what we expect to see. The idea here is, according to our sketch, that if I put in a digit up here, and I'm sorry it's kind of small up in that window there, but I've put in the number 5. When I press enter, we're going to see what our new digit is that's been read from that buffer. So let me press enter, and there you see not a 5, we see a 53. Well, don't be too alarmed by that. What it's displaying is actually the ASCII code of the character 5. In order to get the value 5, which is what we want, we're going to have to do a little bit of manipulation with the data that comes in. And it's quite simple. I can demonstrate this. I'm going to enter a 0 now, and look what we get here. The ASCII code for 0 is 48. Turns out that if we subtract 48 from the ASCII code of whatever comes in, we should have the value of the digit that we entered. Let's go see if we can do that in our code. It says here that the new digit is equal to serial read, but I'm going to add to that minus 48. Let's upload that. Let's bring our monitor back up to the front. I'll put the 5 in again. I touch 5 on the keyboard, and now I press enter, and it shows 5 on the screen. I'll push 7 on the keyboard. I push enter, it shows a 7. Okay, that's looking good. So the next step is to get it back and pull the bit pattern out for the character that we want to display. So if we are going to put in the 5, for example, we need to know that what these digits right here are, so that we can send them out to the shift register on our board. Let's add one more print here. And what I'm going to ask it to do here is reach into our array. We called it segs, and we're going to go into whichever index was entered at the keyboard. That's our new digit, and we're going to print that number on our screen. It'll print out the decimal number unless I tell it specifically that I want this to be in binary, and we want to see those ones and zeros. The bin that I'm adding at the end of this instruction in here is going to tell it to print it in binary format as opposed to decimal. So let's upload that, and we'll give it a try. It says it's done. We'll bring back the monitor. Again, I'm going to enter the number 5. I'll press enter, and there you have it. back. Let's do one more. Remember when we started, we said that if we want to display the digit 0, it's going to light up all the segments except for the crossbar in the center and the decimal point. Our bit pattern was a whole bunch of ones and then a couple zeros at the end. Let's see if that's what we get here. I'll go ahead, I'll enter a 0 on the keyboard. I'll press enter here. And look, there's all our ones and our 2 zeros at the end. These digits here are only part of what we need to do in order to get our character to appear on our panel. Remember, we have 2 shift registers. One shift register is going to light up the various segments that actually creates the digit that we see. The second shift register determines where it's going to be seen. And that's the one that I was calling spot earlier when we were setting things up. Let's get this out of the way. The first thing we have to do is tell the panel where we want to write this. So let's see. I'm going to come in here and let's just say that spot will be equal to, and I'm going to use the binary format, all these ones, 1, 2, 3, 4, 5, 6, 7 ones and 1 0. That means that our character is going to appear in the last position, the furthest right position on our panel. Wherever a 0 appears, that will tell us which digit we're lighting. Now we need to send these out to the shift register, and the Arduino library has a nice little function in it that'll do all the heavy lifting for us. It's called shift out. It requires several pieces of data in order to do it. It needs to know where our data pin is. Well, we've defined that. It needs to know where our clock pin is, and that's been defined. Now it needs to know also which direction are we going to shift these ones and zeros out. What we're going to use is something called LSB first. That stands for least significant bit first. That means that 0 right there is going to come out first. If we put MSB first in here, it would go the opposite direction. It would start with this 1 and go that way. We're going to start with a 0 and go this way. We're going to go backwards. And then finally, it needs to know what is the data that we're sending out. And it will be that binary number with all those 1s and 0s in it called spot. So that's going to go out to our shift register. It's that simple. And trust me now, this instruction that we have right here is going to move these bits right here into our first register. We need them in our second register, but that's going to happen for free, because the next thing we're going to do is I'm just going to copy this line and paste it in here a second time. We're going to do exactly the same thing one more time, but we're going to do it with the data that we read that was in this new segment. So we'll just put that in there instead of spot. We'll go to segs, new digit. You saw them printed on the screen. We'll put those in as soon as we put these in. That will push every one of these digits over into our second register, because we have the data out pin on our first register feeding the data into the data in pin in our second. Once we've pushed all 16 bits into the 2 registers, everything should be in the right place. Now, you watched me in the other video when we were bit banging this, and I'm pushing these buttons and doing all of that. In the end, the LEDs didn't light up until we pushed the latch button. There is no function here doing that for us. We have to do it ourselves, so it's simple enough. I'm going to just write digital write the latch pin 1. That'll send the latch pin high, and then all we have to do is turn it back off again with a digital write to the latch pin 0. That will toggle the latch pin, and it should light up our character on the display. Okay, I will upload this to the Arduino. You should be able to see the lights blinking down there. I'm going to open up my terminal window, get the monitor running. There it says sketch begins. Okay, I'm going to put in the 5 just like we did before. I've entered it up above. I'm ready to push the keyboard Let's see if our 5 comes up on our display. Look at that. A successful run right there. We put the number 5 on our display. Well, this is a great opportunity for me to check my bit patterns. Make sure that when I set up this array up here with all of the characters, let's make sure that they are all right. We'll do that by going back to our monitor, and I will just go ahead here and I will enter all of the digits. We'll look at them down on our display and make sure that they're the characters we expect them to be. All right, let's just go down the line. I'll enter a 1. We get a 1. I'll enter a 2, 2, 3, 4. We know 5 works. 6, 7, 8, 9, and 0. Well done. Now there's a couple of things that we need to really look at and make sure we're clear on. The first one is that you heard me entering digits 1, 2, 3, 4, 5, and you saw those digits appear on our panel. How is it that I was able to just keep entering digits one after another and have them show up? You'll recall that we did write a procedure that would take input from our keyboard and determine the bit pattern that was needed and then shift it off into our shift register. That was pretty clear. But after we got done with that task and we flipped our latch pin, what happens next? The program control goes back to our main loop and it simply waits here for another digit to appear. As soon as I put in the next digit, it goes and does it again. The second digit overwrites the first one in the display, and I'm able to put in any digits that I want to. Now I'd like to direct your attention to something else that might be confusing. Here are the bit patterns that we were using to create our characters. Here's that number 5 again. We have the 1s and 0s. And you saw on the panel that where there's a 1, we are turning something on. That lights up the LED for that segment, and this pattern of segments right here will create an image that looks like the number 5 on our panel. So 1s, we're turning things on. We also have another bit pattern down here that we call spot, and this pattern right here determines which character on our panel lights up. Now look at this. We've got a lot of 1s in here. This seems backwards. It's as if, wait a minute, the 0 is what's lighting it up? How come up here a 1 lights something up and down here it's a 0 that lights something up? Well, maybe we should think of it in another way. Think of it, the 1s determine which digits don't light up. Let me see if I can make this more clear. Look down here. Let's just consider only one LED right now on one digit. So if we were to make a schematic of that, it would look like this. An LED is a diode, which means that the current will only flow through this diode in one direction. Every LED needs to have a current limiting resistor on it. They all have them. And you saw that when we put our board together that we actually have 8 of these on our board. So to get this thing to light up, what we do is we put 5 volts over here on this side, and then we put 0 volts on that side. And when there's this difference in voltage, we call it potential. When there's a difference in voltage, when the cathode has a lower voltage than the anode, the LED will light up. What we're doing with the cathode over there is putting 5 volts on this side. So in this situation, 5 volts on this side and 5 volts on that side, there is no difference in the voltage. Therefore, there's no current flowing and the LED doesn't light up. That's how we use those ones to turn the digit off. So let's go back to the panel one more time. Bring it in here. Each of these digits has its own common cathode. That means that all the cathodes in these segments right here that are lit up are tied together as one cathode. The anodes, however, have their own connection, and each of them has its own resistor. When we look at the whole panel, we find that each digit has a separate cathode that works for every segment. But each segment has its own anode, and that anode is connected to all of the 8 digits. So we have a cathode and an anode combination. When we put the right ones together, we can light up whichever segment we need. Let me demonstrate this even further. We'll go back to the sketch. Let's look again at this bit stream right here. This is what we call spot. This is what determines which digit on our panel is going to light up. And we've got all these ones. There's 7 ones there. That means 7 of the cathodes are all high. 7 of the cathodes are all at 5 volts. Only one cathode is low. That one cathode is at 0 volts. It's the digit that has the 0 volt cathode that's going to light up. Let's play around with this a minute here. What if I put 2 zeros in this number? Let's upload this to our Arduino and see what happens. I'll bring up our monitor so that we can enter something here. There, sketch begins. I'll put in the 5 again that we've been experimenting with. Watch the panel over here when I press enter. Aha! We've got 2 5s. We've got 2 5s because 2 cathodes are down to 0 volts. If I change the digit, I'll enter 3, say. They both change to 3. Here's a 7. They both change to 7. We can see that the bit pattern right here will determine which of the digits on our panel is going to light up. And we put in this extra 0 here, which kind of is not very practical because it just gives us 2 of the same digit every time. But I want to show you some cool things that we can do with bits. Let's make all of these 1s. Now, if we were to run the program right now, you could probably see that the results would be that none of the digits would light up because they're all 5 volts. There's a function in the Arduino library that's really convenient, and it's called bit clear. Let me type this in for you. Bit clear. And it takes 2 parameters. First is what is the name of the variable that we want to manipulate, and our variable here is called spot. And then the second one would be which of these digits would you like to clear. If I put in a 0, for example, right there, we're back to what we've always been doing. What happens is that spot is set up, it's all 1s, all 8 bits are 1, and then we take and clear the 0 bit. So that is the 0 bit right there. The 0 bit would become a 0, and it would look just like what we've been demonstrating all along. If I say turn that to a 7, then what would happen is that this bit over here would become a 0, and the digit on our panel that lights up would be clear at the other end. Well, let's have some fun with this. So instead of actually putting a value in here, let's put in our variable. We use the same variable that we've been using for our digit. Basically what I'm saying is, if I enter a 7, this digit way over here on the panel should become a 7. A 6 should go there, a 5 should go there, and so on. Let's play with it and see what happens. I'll upload it to the board. Okay, I'm going to enter a 0 to start things out with. That should clear the 0 bit on our cathode array, and we should see a 0 appear right here in this position. I've got the 0 in the monitor. I'll push enter, and yeah, there's our 0. Now I'm going to enter the number 1, and notice it's appearing now in the next position. We'll do a 2, a 3, a 4, a 5, 6, and a 7. I hope that makes sense to you. Let's go back to the sketch. If we're going to store numbers that have more than one digit, we're going to have to add a lot more to our program. The first thing I'm going to do is I want to make sure that I have somewhere to keep the number that I want to display. So I need to set up another array. We have this array that contains the bit patterns for all of our digits. I want to create another one which will contain the bit patterns for the digits we want to display. And we'll be able to fill that in later in the sketch. All I'm going to do right now is just initialize it. I'm going to call it my number deck. Think of it like a deck of cards, and these are the digits I want to have show up on the panel. There are 8 segments in the panel, so I'll set this array as being 8 elements. We also need to know how many digits we're planning on displaying, and we picked that up here when we came into our get digits procedure. Num digits will contain a value equal to the number of digits that I've entered on the monitor. So far I've only been entering one at a time, but we could enter more than one, and num digits would tell us exactly how many there are. I'm going to set up another integer here to kind of keep track of things. It will be a counter. I'm just going to call it I. I'm going to have it equal the number of digits, but I'm going to subtract 1 from it. And the reason I'll subtract 1 from it has to do with the way in which arrays work. The first element of an array has an index. It's called 0. So the first one is 0. Index number 1 is our second digit. So there's this offset. It goes 0, 1, 2, 3, 4, 5, 6, 7. That's 8 elements from 0 to 7. Now I'm going to just set up a simple while loop here. The while loop will read all of the digits that are coming in. So what we do is, as long as there is data available, our buffer has data in it, we'll just sit here and read that data, and then we will fill up that array that we created. We'll take this line that we had up here and let's move it down in here. Now, we can't just keep reinitializing new digit over and over again, so I'm going to have to take this init out of here. We're going to need to put it someplace else. Let's stick it over here for now. We've got one going there. We'll put it in here. So it's initialized. So now we're going to read this here. As long as there's data coming in, it'll just keep reading these digits, and then we need to put them somewhere. So we're going to put them into position I of that new array. So I'll add that in here. We'll just say that number deck element I is going to equal the bit pattern that's stored in our array of segments for the incoming digit, our new digit. That stores that there. Now remember, I is equal to the number of digits that came in minus 1. So we're going to fill this array up from the bottom up. The first digit that we read is going to go into the last element in the array. Then before we read the next one, we need to move up a notch. So I'm just going to take I and make it 1 smaller. This decrements I. This should then collect all the digits that I've entered and store them in our number deck. Okay, now let's get these bit streams out of this array and out onto our panel. So I'll make sure that I is 0 when we start all of this. Realize that I took the first digit and put it at the bottom of the array, and the last digit is at the top of the array. And this will become real obvious when you see it over on our display panel. So we'll come back to that concept here in a minute. But we know how many digits we have right now. We'll set up a loop to deal with all of the digits that have come in. So maybe if it's only 3 digits, that's fine. So I'm going to set up another while loop, and we'll use I again. And we'll say that as long as it's less than the number of digits. Then we will take these guys out. We don't need to print this stuff anymore. I'll remove those, move some stuff around here. And then we need to clear one of the bits to determine which one we light up, and this will be easy because it's I. The first one we put on will be that 0 right there. So that'll go in. We've done that. Then we'll take that bit stream and send it out into our clock register. Now the second stream of data that we want to send out there is going to be, let's call it our data, and it's going to be the data that is stored in our number deck. And it will be from position I in that array. Now, I don't think I have data initialized yet, so let me add that as well. I'll put it up here. It should be a byte. And get it all set up. So that data is our bit stream. And then we're ready to send it out, which we can do. We already know what the segments are. They're stored in our array. All we have to do is put in data right there, and it should send that stream out. And then we will latch our pins right here. And we're going to go back and do this over and over again until we've done all of our digits. Now, this is going to happen quite quickly. So I'm going to add a little delay in here of, say, 500 milliseconds so that you can see it all happen. Let's see if we get any errors. I'll try uploading it. Yeah, what's it saying to us right now? Oh, you know what I did here? Somehow I had my shift key down. That was supposed to be a 0. The same key, just didn't have my key down right. Let's try that again. One more thing, I almost forgot to do this one. We're going the other direction now. So this time we need to make I 1 larger each time we pass through here. So we'll put that in, and I'm ready to upload it to the Arduino. That worked. Let's bring our monitor back out. Okay, we've got the monitor open now. Let's enter 1, 2, 3 over here on the screen. Back down here on our display, I'll push enter, and let's see what happens. There's 3, 2, 1. Let me try again. I'll put in 4, 5, 6, and it shows us 6, 5, 4. Okay, let's put in 7, 8, 9, and it shows us 9, 8, 7. Let's put in 0, 1, 2, 3, 4, 5, 6, 7. And it shows us 7, 6, 5, 4, 3, 2, 1, 0. We're getting closer. What you just saw was our sketch displaying each of the digits in the number that I entered. But in the end, it only shows one of them because it only displays one at a time. So you saw the last digit that we sent to the panel displayed at the end. We need to keep sending these same digits over and over again to maintain the whole display. So we're going to put another while statement in here. This one will be similar, but quite the opposite of what you've been seeing me do before. This time, we're going to look at that serial input buffer, and we're going to see that is it still empty? In other words, is the buffer equal to 0 this time? And if it is, that means that no new numbers have come in. We'll display the old one over and over and over again until a new one becomes available. So let's see, we got to get down here, and we need to close off this loop as well. This is looking a little sloppy here, but we've got a bunch of braces in here. That one, of course, matched up with that one there. That looks good. I'm going to upload this to our board. But I guess we better spell the word right, or it's not going to work. Much better. We'll upload that to the board. We'll go back to our serial monitor. Okay, we got the monitor going. I'm going to enter 1, 2, 3 over here. Before I press the enter key, let's see if we can make the lighting a little more visible over here. I'll back off somewhat on the light and pull it down a ways. Make the digits show up a little better over here. Okay, we've got 1, 2, 3 over there in the serial monitor. I'm going to press enter. Let's watch what happens. Okay, we are rotating through our digits. 3, 2, 1, 3, 2, 1, 3, 2, 1. Now, you recall that I said there was a reason I would flip the numbers around backwards. The first digit that we put on the display, the 3, goes over here in the 0 section. If we number all these digits 0, 1, 2, 3, 4, 5, 6, 7, the first one is the last digit that I entered. That's why I went to all the trouble to create those bit streams and put the digits in the opposite order of what you might have thought. Let's try a different one here. We'll put in 4, 5, 6, and I'll enter it, and there you see now we have the 6, the 5, and the 4 going. One more. We'll do 7, 8, 9, and how about let's do the whole set. We'll go 0, 1, 2, 3, 4, 5, 6, 7, and there they go. We're zinging them along right there. I'm going to go back to the sketch here for a second. Remember, we only see one character at a time, so we have this 500 millisecond delay in here. Let me drop that down to 50 milliseconds. I'm going to upload that. Bring up my monitor again. And let's put that 1, 2, 3 in there again. I press enter. And now you can see they're really rolling. And you're starting to get a sense that maybe there is the number 123 there. Remember, only one digit is lit at any given time. Well, let's go back to the sketch one more time. Let's take that delay out completely. I'll just rem it out. We'll upload. And when it's done, I need my monitor back. And I will put in, let's go 1, 2, 3, 4 this time. 1, 2, 3, 4. I press enter. And look at there. We've got our digits 1, 2, 3, 4 displayed. I can put in any number I want to put in now. I could put in 1995, 1995. I press enter. 1995 is right there. You like the year 2020? Here's a 2020. I can put anything on there. I could just put several digits in and they all appear over here, just like that. Things really came together fast there at the end, and I certainly hope you were able to follow all of that. For one thing though, I'll put a link in the comments down below to a GitHub page where I will post the sketch that we wrote here and some other sketches that demonstrate how to use this panel so that you can experiment with it and do your own projects. Well, that pretty much brings us to the end of not only this video, but the entire series that we've been working on in designing your printed circuit boards. And I would especially like to thank JLC PCB, who sponsored this entire series. They do a wonderful job, and I really enjoy working with them. The quality of their printed circuit boards is the best. And I certainly hope that you will give them a try yourself. Design your own printed circuit board, send it up to them, wait for it to come back, and see what you can do. Now, if you come up with something interesting, tell us about it in the comments. Thank you for watching these videos. And hey, don't forget to subscribe, like, and share.